Yeah, it's not too hard. Oh, did you take the math thing? Was there any geometry on it? Did it? Oh, okay. All right, let's take a look at this. All right, here we go. You ready? All right. Got a circle. Got a center of the circle. We've talked about all that. And here's the radius of the circle. But watch, I'm going to put another radius in here. Let's say put it about right there. Okay. Look what I've made. I've made an angle inside the circle, haven't I? All right. So we've got an angle right there. But we've also created something else. Look where this radius hits. Hits right here and it hits right here. Okay. Now you've probably learned this before. Like if you turned all the way around, how many degrees? You can measure things in degrees, can't you, with circles? So if I'm here and I walk all the way around that circle, how many degrees is that? 360, right? Okay. If you go all the way around, that's a complete 360, right? People use that all the time. Skateboarders and people like that. I'll do the 360, or basketball players did a 360 dunk. You ever hear of that kind of stuff? Yeah. I've actually heard some preachers say a lot. They mean to say 180, but you ever hear anybody say that? You know, and he turned his life around 180 degrees. You ever hear people talk like that? Yeah, people say that all the time. But I've heard preachers say, and he turned his life around 360 degrees. I'm like, well, I guess he's going the same way where he started. Okay. But they didn't mean that. And of course, I don't raise my hand and stand up and correct them. Excuse me, sir. No, I don't do that. But I've heard that before. So there's definitely degrees associated with circles. Would you agree with that? Yeah, absolutely. So if you go all the way around, that's 360 degrees. In fact, we've talked about that before. If I put like an X and a Y axis here, if we go to the very top of that, how many degrees was that? 90, and then over here was 180, down the bottom was 270, and over here was 360. Okay, so we've talked about that. We've actually just finished talking in that last section about the distance around a circle, correct? Well, this time we're not talking about going around the whole entire circle. We're just going to talk about going around a little part of the circle. So let's make this, how about red? So watch this. If I go from here, and if I can tracing skills aren't that great. That's not too bad right there. That's close. It's off a little bit. That's okay. I'm fine with that. All right, so what I've done is I've gone from here to here. This is not 360. It's not 90. What do you think this is? It's between what and what? It's between 0 and 90, right? Okay, so this would, let's say this was 0 degrees right here, and this was 90 degrees. This would be between 0 and 90. We call this thing right here, this part of the circle, okay, it's a section of the circle. It's not the whole circle, right? It's not half a circle. Okay, it's just a section of the whole circle. We call that an arc. All right, so anytime that kind of bugs me that white is kind of sticking out there. That still didn't cover it, did it? Did I make it worse? Yeah, I should have made it really thick. Anyway, that's good enough. All right. So that part right there is bugging me. Why can't I hit that? There we go. Okay, sorry. So that thing right there is called an arc. Now watch this. An arc is also measured in degrees. We just discussed that. We said if you come up to here, that's 90 degrees, 180, 270, 360. So you can measure, okay, the angle around a circle, I guess if you want to call it that. And this arc also has a measure, and it's also measured in degrees. So we measure an arc in degrees. Let's put some letters in here. We'll call this A, B. We'll just call this X for the center, okay? And so I can also name this arc. This is how I would name the arc. Well, it goes from point A to point B, so guess what we're going to call it? Arc AB, right? So actually, let's not do it like this. Let's do it like this. AB. And here's the symbol for an arc. Yep, it's like that. Okay, that's the symbol for an arc. It makes sense, doesn't it? And so we put it over just like that. So that's arc AB. Now, or I could call it something else. What else do you think I could call it? Does it really matter that we start at A? Yeah, I could call it arc BA. Let's not just call it BA. Let's call it arc BA. So I could call it arc AB or arc BA. All right, doesn't make any difference. Okay, Aberbath, right? Aberbath. All right, so it doesn't matter which one we call it, but it is called an arc. And an arc is also measured in degrees. Now, here's something that's kind of cool. This is an angle right here, but where is the angle made? What's the vertex of this angle? It's the what? Now, the vertex of the angle is the center of the circle, isn't it? Okay, so when you have an angle that's formed at the center of the circle, we call this the central angle. All right, not much of a stretch, is it? All right, it's the angle at the center. Okay, the angle at the center is called the central angle. And that's pretty important because this is like the first step in what we're going to do. We're going to do a lot of different relationships between arcs and angles and things like that. This is the first one. It's the easiest one. That the central angle is equal to the arc, and they say that it cuts off, right? So if we took this and went to here, right, and then we went from the center to here, it cuts off that arc. Do you see it? You can kind of picture that, can't you? Chop, chop, right? You got that arc right there. So the central angle is actually equal to the arc that it cuts off. Make sense? So if this was 40 degrees, if this angle X was 40 degrees or angle BXA was 40 degrees, what do you think arc AB or arc BA is equal to? It's also equal to 40 degrees. It's exactly the same. That's only true when it's the central angle. Everybody with me on that? All right, so it's true when it's the central angle. It's equal to the arc that it cuts off. All right, that's kind of nice. And it kind of makes sense. It's not obvious right now, but I bet you if we do this, it might make it a little more obvious. Watch, if I went to here and I went to here. I went horizontal and I went vertical. So what kind of an angle did I just draw inside of here? This is 90 degrees, isn't it? So look, remember what we said before? From here to here, what do you think that arc is right there? 90 degrees. So if I call this 0 degrees, where did I end up? At 90 degrees. Remember we did that with a vector thing in that other lesson? Yeah. So that's a little bit obvious, isn't it? Would you agree? Yeah. Or watch this. If I took this and stretched it all the way across to here, that's right. So this angle, that's a straight angle, isn't it? From there to there. So what kind of arc does it cut off? Cuts off a 180-degree angle, doesn't it? Does that make sense? So it's kind of obvious when you see stuff like that. So if it makes sense there, it should make sense that this central angle is going to be equal to whatever that arc is that it cuts off. Make sense? Okay, good. All right, so that's central angle. That's good stuff. There's a little example. I'm not going to go through it. I think you can look at it yourself. I don't think it's that hard. It's on page 692. So you can look at that example. What's that? I can't hear. You're whispering. Okay. Like this? Okay. Oh, that's it? You just wanted to see it? All right, let's do this. Let's put another circle in here. And we're going to talk about a couple different types of arcs. Let me make this just a little bit bigger. Now, we already talked about one type of arc, and we said it was less than 90. In fact, let's talk about, let's label these A, B, and we'll call this X again, all right? Let's talk about this arc right here. So this angle X, or AXB, is equal to arc AB, isn't it? Okay, so we know that already. But let's take a look at arc AB. So I'm going to try to, we'll make it 4-point, make it real thick. What do we want? Yellow. So that's okay. It will. Oh. Yeah, a little squiggly. I'm sorry. I'm a little nervous. Okay, it's very stressful trying to keep within the line. Okay. So anyway, oh my goodness. Okay, this is it. This is my last shot at it. So I'll be a little. Oh my goodness. Sorry, I lied. It's not my last shot. It's not as easy as you think. Nah. That's a little better. I'm a little wiggly in here, but that's okay. Good enough. Okay, now look at this arc right here. Now tell me something about this arc. This arc, it's less than 180 degrees, isn't it? Because 180 degrees would go straight across right here. So this is less than 180 degrees. We call, oops, that's a little thick. Let's go back to 2-point. Okay, this arc right here is less than 180 degrees. We call this a minor arc. Minor arc. Okay, and it's less than 180 degrees. So any arc that's less than 180 degrees or between 0 and 180 degrees would be considered a minor arc. Now, a minor arc we can label just like we talked about before. I could just call it arc AB. Right? I only need 2 points to name a minor arc. But what if I did this? What if I put a point right here?
Dismiss middle school baseball at this time. At 2 o'clock, please dismiss boys and girls varsity lacrosse. 1:45 today, baseball middle school, and then 2 o'clock, lacrosse boys and girls. Thank you.
All right, look at this arc right here. Now, this is going to be awful because there's no way in the world that I'll be able to... And you can laugh at me all you want. I don't care. Boom. Okay, look at the red one right here.
Actually, wasn't that bad.
Yeah, I went a little faster, so it's a little bad right here. Okay, this thing right here, is that arc less than 180 degrees or more than 180 degrees? It's greater. So if it's, we'll talk about that in a second. Okay, if it's less than 180, we call it a minor arc. So guess what it's going to be if it's more than 180? How about a major arc? Okay. Could there be any more announcements?
Please excuse the interruption. The girls' varsity lacrosse game has been canceled for today. There will be practice instead from 3:30 to 5:30 today. Thank you.
All right, so more than 180 degrees. Okay, the major arc is more than 180 degrees. Now watch. Now that's a fairly important, I guess. It doesn't really matter that much if you know the name of a major and minor arc. But here's what's really important is how you name it. Because if I just said AB, how do I know I'm not talking about this red arc right there? If I just said AB, how do you know I'm talking about this arc and not from here all the way around to here? Wouldn't you agree? That could be a possibility, couldn't it? If I said arc AB. So if I just go from A to B, it depends on which direction you're going to go. But a major arc, we're always going to use 3 points. Okay, you'll always use 3 points to name a major arc. So if I wanted to talk about the red one, I wouldn't call it arc AB because that could get confusing, right, on which one I'm going to use. So what would I call it? I could call it arc what? ACB. That's right. So if I start at A, I wouldn't go ABC, would I? Because it doesn't really go from here to here to here. It goes from A, it goes through C, and it ends up at B. And so on a major arc, I would use 3 points, not just 2. So you only use 2 on a minor arc. You with me on that? Yeah. Okay. That's pretty easy, isn't it? So I would call it arc ACB. Or I could go the other way. I could call it arc what? Or I could call it arc BCA. What could you not call it? You couldn't call it like ABC. You couldn't call it BAC, right? You got to go in order. If you start at A, you have to go in order to get to this thing right here, okay? Now, C could be anywhere. I mean, it could have been up here. It could have been down here. It doesn't matter. It doesn't have to be like right in the middle or anything, okay? It just has to be somewhere in between. Make sense? All right. Can I what? Pink? All right, we could probably use pink on this next one. So, let me draw another one. Morgan, what did you ask earlier? You said, can you have a... I talked about minor arc and major arc. I thought it was you. Who said that? Brooke, you said that? Okay, you said that? Right. I knew somebody was in that direction. Okay, so, yeah, let's talk about that. I guess I should put it on all the way across right there. Okay, what if you had this? Now, this is an angle as well. We just talked about this a few minutes ago, didn't we? So this is an angle. How many degrees is that angle? 180 degrees. So it's not a minor arc, it's not a major arc, because it's exactly 180 degrees. And I heard you guys say it already. It's a semicircle, okay? And you've probably heard that before. So a semicircle, semi, however you want to say it, doesn't make any difference. Okay, a semicircle is 180 degrees. It's equal to 180. It's not less than, not greater than. It's exactly equal to 180 degrees. That's a semicircle. Now, let's put some letters in here. We'll just put a B right here. We'll call this C right there. All right, now how do you think you would name the semicircle? Could you just say AC?
No.
Because, well, if you said arc AC. Well, but you're not sure which one you're talking about. Because I could go... I could go arc AC. They're equal in measure, but they're not the same exact arc. Like if I told you to walk, right, along the arc AC, would you necessarily, like if you and a friend started walking, would you necessarily go in the same direction? No, not necessarily, because it doesn't matter. It's the direction that you're traveling. Okay, so if I said walk along arc AC, one person might go this way and person might go this way. It's the same distance you get there, but that's not the point. Listen, it's not the point. The path that you traveled is a different path, so that means it's a different arc. Even though it's equal, right, in measurement, it's still a different arc, completely different arc. You're going in a completely different direction. All right, so if I wanted to say I was going over the top of this thing, what would I say? I would say ABC, and that's really super thick. Let's do this. So ABC, arc ABC would be this top one, right? That would be this arc right here, or this semicircle, right? Or if I wanted to go down below, I could call it what? Arc ADC. Of course, you can go backwards on it. Okay, that's understood now, I think, isn't it? All right. So even though it's the same measurement, still 180 degrees, it's still two different arcs. We good with that? All right. So we got a semicircle, we got a minor arc, we got a major arc, and I think we're good with that stuff. Okay, let's do this little bit right here. Trying to get through it for those. Who's actually leaving at 2 o'clock? How many people are leaving? Nobody's leaving now? Oh, they just canceled it? Don't know. Don't know why. Right. Yeah, so they were taken by surprise as well. Alright, so let's call this X, and we'll call this, I don't know, QRS. We'll be different a little bit. Getting tired of the ABC, aren't you? Alright, let's take a look at this. Let's make this just a little thicker. Here we go. Alright, what about this? What they're saying is it's called arc addition, okay? Or you could even look at it as angle addition. Watch, if I wanted, we'll call that angle 1, we'll call that angle 2. Is that alright? So angle 1 plus angle 2, and don't say angle 3, right? Angle 1 plus angle 2 would equal what? Angle QXS. Angle, that's weird, QXS. Different color? You don't like that color? It's annoying. Okay, I could, green. Which green? That green? How's that? Is that better? Okay. Alright, so the same thing would hold true with an arc. Alright, it's really not that much different. Somebody said pink, so let's go pink. What if we did this? What if I said arc QR plus arc RS would equal what? What? QR and RS would be what? Q. All you have to say is QS, though, isn't it? Now, if you wanted to, you could say QRS. All right, it wouldn't be wrong if you did that, but you could just say QS because it's the shortest way, right? It's a minor arc. It's less than 180 degrees, and so you could just say arc QS, and that would be perfectly fine, all right? And that's just arc addition is what they call that thing, arc addition postulate. All right, let's do one more thing, and then maybe we'll hit a few examples. Is that all right? Let's scooch this down again. Which one did I skip? 10-1? Yeah. Yeah. Just finished doing that. Oh, whatever. I said theorem. It's a postulate. You know. I mean, it's kind of the same thing. It's just... I don't think there is. Where at? 690. Congruent arcs. Oh, okay, yeah. Let's do that one then. Okay, I did skip over that. I was just a mistake. I just scanned over it. Yeah, this is pretty easy. Let's do like this. Let's go like that, and like this, and like this. Okie doke. What if I said this was angle 1, angle 2? I'll just use the same letters they use, F, G, H, and J. All right, so the theorem at the bottom of 693.10.1 says, let's say they told you that angle 1 is equal to angle 2. Now, they're not equal to each other because they're vertical angles, are they? Because they're not vertical angles. But let's just say I told you that 1 and 2 are equal to each other. What do you think you could say about the arcs without even knowing the actual measurements of angle 1 and 2? You could say that what? That what arc? Arc FG would equal what? JH, right? Or HJ, doesn't matter which way you call it. Okay? And that's all that thing is saying. Okay, so if you have two equal angles, the arcs have to be equal to each other as well. Make sense? So if this was like 70 degrees, if arc FG was 70 degrees, and that's how you would mark it. You just put it in between there. That automatically means whatever's between F and G is 70 degrees, okay? So if I told you this was 70 degrees, and that's the only thing I told you except that 1 and 2 are equal to each other, what could you say about JH? That would be 70 degrees as well. That's all that's saying. That's pretty easy, isn't it? It's almost common sense, wouldn't you think? All right. Okay. All right, let's do another. Let's see what I'm going to do. Okay, I want to do this. We just finished talking about the circumference of a circle, didn't we? Circumference is basically what? It's the distance around it. So if I went here and I went all the way around, and to get to here, that would be the circumference. And how did we find the circumference? 2 pi r, or pi d, right? Same thing. But this time, we're not going to go all the way around the circle. We just want to go just a part of the circle. Let's say about right there. And let's say that this was 60 degrees. All right? With me? What I want to do is I want to find out how far is it just between A and B. Now I need to put a radius. Let's just make up a nice easy radius. We'll say it's 5. Okay, so the radius is 5, the angle is 60 degrees. I want to find out how far it is just between A and B. Oh my goodness, I'm getting worse at that. I know, it's okay. Just deal with it. All right. So I want to find out along that circle, that arc right there, AB, I want to find out the length of it, the distance. Is that just a straight line? No, it's not a straight line. It's a curve, isn't it? But it's part of a circumference. It's like you took a part of that full circle. Well, how much of the full circle did you find? 60 degrees of the whole circle, right? Or 60 degrees out of 360. That's right. Good. Does everybody see that? That's really important right there. So we're not finding the whole entire circumference, are we? We're just finding 60 degrees out of that whole entire circle, because that arc would be 60 degrees, wouldn't it? Because it's equal to the central angle. So that's 60 degrees out of the whole entire circle. So it's really only 1/6 of the whole circle, isn't it? Right? But if I want to find that distance around here, what am I going to do with that? It's not just 1/6. I don't just say the distance from A to B is 1/6. It's 1/6 of the whole circle, but how would I find the distance around the whole circle if I wanted to? 2 pi r, the circumference, right? So this is what? This is just a fraction of the whole entire circle. It's 1/6 of the whole circle. But what's the whole circle? It's 2 pi what? R. And what is the r in this situation? It's 5. You could do it all kinds of different ways. If you wanted to simplify the fraction, you could. But sometimes it's not going to be that nice. Sometimes it could be like 57.3 degrees. That's not going to simplify nice, is it? So you just stick all that in your calculator. All right? And it's just basically putting all that in your calculator. This is this fraction of the whole circle. That's the whole circle, isn't it? This is just a fraction of the whole circle. Morgan, you had a question? No. Okay. All right, and then you can just stick that in your calculator. What's that?
What if it's like the other
Is
way?
that
They
everything?
tell you the other line.
What if they tell you what other line?
Oh, it's the same line. Like
Yeah, it's a radius, yeah. If I call this x, right, xa and xb are the same exact thing, aren't they? Because they're both the radius.
Yeah.
Yep. All right, so let's do this. 60 over 360s, so 60 divided by 360, right, equals that. And then you can just a little bit of this in your head, right? Times what? Times 10, right? And then times pi. And pi, where is pi? It's right here. Boom. Equals, there it is, 5.2. Let's just say 5.2. All right. So what does that mean? What did I just find? What did I just find? I found the distance. I found the length of the arc. That's right. I found the length of the arc. And what they do is that they just use that word. Find the length of arc AB. Yes. Okay. Yep. Let's say it's in inches. Let's say I put it in inches. Go ahead.
Okay, for like example one, how it's just like adding them up. Like,
example 1. Yep.
do we have to like on our homework? Do we have to show like we're adding whatever it is, 130 plus 90 plus angle?
Well, I'll tell you what. I mean, you really should show what you're doing. I mean, you should show, you know, how you got the answer. I mean, look, even if it's right. Here's just a general. Here's my general opinion on it. Okay, let's say you had number 1, right, on homework, and the question was 3 plus 2. Okay, I know you can do that in your head. I know you can just write down a 5. Okay, but I want to see 3 plus 2 equals 5. I want to see all of that. Okay, so if it's a matter of just subtracting something, like if you wanted to find a missing angle, you know, if you had supplementary angles, right? And the one angle is 30 degrees, and you wanted to find the other angle, the supplementary angle. Okay, you can do that in your head, right? 180 minus 30 is 150. But I want to see this. I want to see 180 minus 30 is 150. This is what I want to see. All right? It's a good habit to get into. All right? You're not always going to have problems you can just do in your head. You're going to have to be able to rely on showing your work, and it should be very helpful. I'm telling you, I think in the long run, showing your work will really, really help you out. So here's, let's do that example. This is weights. Okay. All right, look at this. What if I asked you to solve for x? And here's your picture right here, and I asked you to solve for x. Okay, so 130 plus 90 is what? 220, right? Right, and then 360 minus 220 is 140. There you go. And you have your homework. Oh, you don't have that much time anyway. Let me do another. I know. Let's do another example. Just want to make sure we do this. I mean, what's 2 minutes? 2 minutes to do your homework's not really. Oh, stop. That one's too easy. Let's do this one.
Mr. Hammer, can I ask you to please send Gabrielle Donovan to the office for an early dismissal?
Okay.
Thank you.
You're welcome. She can look on my book up there. It'll tell.
What?
She can look on the book. You know how I always put them. All right, watch this. They put 14 meters right there. They put 80 degrees right here. And they say, find the length of arc AB. Here's AB. All right, so find the length of arc AB. It's very simple, okay? It's not difficult at all. So what would you do? You're finding this length from A to B. Right, the radius is 7 because they put a 14 here. The 14 is representing the whole diameter. So the radius is 7, isn't it? So what do we do? $80 over 360 times 2 times pi times the radius. What's the radius? 7. So it's 14 pi times 80 over 360. Stick it in a calculator, you get an answer. And that's all there is to it. It's 9.77 if you want to check to see if you did it right. All right. Let me give you some homework. Never had a class so eager to get their homework before. Oh, that's right. Too many. I hardly ever show you examples, and I finally shown you examples.
Show us examples. This chapter is too
I
easy.
finally showed you examples, and all right. Pages 696. Well, basically, it's just a matter of the time that I had available. So I actually had time available, so I will do examples for you. There it is. All right, enjoy your homework.